come help me with the tree, please?
Yeah, I've got some candy right here. Oh, ow. Why am I so clumsy?
You're not clumsy. There was just less friction between you and the floor.
What do you mean there's less friction?
Well, friction is the resistance between two objects, and your fuzzy socks and the smooth floor barely had any, so that made you slip.
Let's learn more about it.
So, Emily, what exactly is friction?
Good question, Juliet. Well, friction is the resistance between two surfaces when one object attempts to slide across another.
Also, friction depends on the interaction between the stickiness and the bumpiness of surfaces.
And don't forget that friction always opposes motion. So if the motion is going this way, the friction will be going that way.
If the force increases, the friction will decrease to compensate.
Hey Juliet, why did you buy winter tires for your car?
Because in the winter, there's less friction between the tires and the roads, because usually the roads are covered with snow and ice.
Oh, that makes so much more sense. So the winter tires have deeper grooves and they have a specific pattern which makes the coefficient higher, and they have more friction between the roads and the tires.
Yep. Hey, let's do an experiment to show this.
Alright. For this experiment, we'll be using Hot Wheels for safety reasons instead of Juliet's nice car, and small inclined plane, a smooth table, and burlap.
We'll also use color pencils and a scarf. This experiment will be able to show how different surfaces impact moving objects.
And we'll be observing how friction affects an object in motion. Alright, for the first surface, we'll be using just the table, which is very smooth. And then we will always put it at the back of the inclined plane just to make sure that the results are always the same. So here we go. And then it went about 58 inches. So the next surface we'll be using is this burlap, which is a little bit rougher. And then we'll always put it at the end of the inclined plane. So 3, 2, 1. And then this time it went about 23 inches, which is shorter than last time.
So now we're using the markers as a surface, which is way bumpier than the burlap. And this went 13 inches. So now we're using the scarf, and we predicted that it's the one that creates the most friction, so let's see if we're right. And we were. This one is 12 inches.
Oh.
This experiment showed that the stickier or the bumpier a surface is, the more friction there will be and the more force will be needed to move an object. The scarf created the most friction, then it was the markers, after that the burlap, and the one that created the less friction was the smooth surface. So if an object is not moving, does that mean that there's no friction?
No, if an object's not moving, there's still friction acting on it, and it's called static friction. The vector sum of the external forces acting on the body is equal to the magnitude of the frictional forces, but still in opposite directions.
Is there a special name for friction that is moving?
Yeah, Juliet, it's called sliding friction. Do you want me to show you right now?
Right now?
Yeah, right now. We just need the sled that we're leaning on and a couple different surfaces. Come on, Juliet, we better go in the snow. It's kind of hard, though. You must be eating too many cookies in the winter.
There's just too much friction, Emily.
Are you sure?
Yeah, I am.
Let me get a scale. Okay, Juliet, let's see if you actually did your workout like you're supposed to. Ready?
Emily!
Ah! Looks like it really paid off for a quick break. Wow, Juliet, can you tell me how you lost so much weight between going from the snow to the driveway?
Emily, it's just friction.
What do you mean?
Well, there's less resistance on the driveway
Why?
because this surface was smoother than the snow.
Oh, kind of like the Hot Wheels experiment?
Yeah, exactly.
So like the smooth table, the car went farther. In fact, even though it had the same distance that it let go on the scarf, but the scarf, it didn't go as far.